How does a big file fit through the wires of the internet without breaking? Imagine you have one large file you need to send. If you tried to send it all at once, it would be impossible to manage. Instead, the internet breaks that file into tiny, manageable pieces called packets. You can think of your total data as the sum of all these individual parts. Now, each packet needs a way to find its destination. Notice how these labels appear at the top? This is the header, which acts like a physical address on an envelope, telling the network exactly where each piece belongs. By including this address, each packet can travel independently toward the recipient. Once they arrive, they reassemble back into the original file, just like putting puzzle pieces back together. Packets make data manageable. How do computers agree to talk? Meet Alice and Bob, two computers trying to establish a connection. Alice starts by sending a SYN signal to Bob. This is a synchronization request that tells Bob she wants to talk and sends over a unique starting sequence number to help organize their future messages. Bob then sends a SYN-ACK signal back to Alice. This acknowledges her request and shares his own sequence number so they can keep all their data in the right order. Finally, Alice sends an ACK signal, or acknowledgement, to confirm she received Bob's message. With this simple three-way handshake, their connection is now reliable and secure. Both computers turn green, signaling they are officially ready to flow data. Have you ever wondered how you can be sure that your data does not get corrupted or lost while it travels across the internet? When you send information from a source to a destination, packets can sometimes disappear or get garbled in transit. This leads to errors that prevent your files from arriving correctly. Think of it like a relay race, where one runner passes a baton to another. If the runner drops the baton, the race cannot continue. They must go back, retrieve the baton, and start the sprint again to complete the transfer successfully. In digital systems, we use a tool called a checksum to detect these errors. This is a mathematical formula that adds up bits of data to verify integrity. If the sum does not match, the receiver sends back a negative acknowledgement, or NAK, to signal that specific data is broken. Once the sender gets that message, they only retransmit the corrupted piece, ensuring the full set is finally complete and accurate. This process of selective retransmission allows for efficient recovery, making sure your digital information arrives exactly as it was intended.